Hi, welcome everybody. Today we will have a class on mathematical induction. How we can prove a mathematical statement by the principle of mathematical induction. What is the step-by-step procedure to prove a mathematical statement? Okay, step number 1. Write the statement as P of n. Step number 2. Prove that the statement is true for n equal to 1. That is, P of 1 is true. Step number 3. Assume that the statement is true for n equal to k. That is, we assume P of k is true. Step number 4. Prove that the statement is true for n equal to k plus 1. That is, P of k plus 1 is true. Therefore, the statement is true for all natural numbers. This is the step-by-step procedure to prove a mathematical statement by the principle of mathematical induction. Now let us see a question. See the question. Prove sigma I varying from 1 up to n of 2i is equal to n times n plus 1. When we expand the sigma notation, we will have 2 times 1 plus 2 times 2 plus 2 times 3 plus etc. plus 2 times n is equal to n times n plus 1. That is 2 plus 4 plus 6 plus etc. plus 2n is equal to n times n plus 1. Okay. What is the first step? We write the given statement as P of n. Okay, what is our P of n? P of n is sigma I varying from 1 up to n of 2i is equal to n times n plus 1. Now what is the next step? We prove that the result is true for n equal to 1. Put n equal to 1, then we have sigma I equal to 1 over 1. 2 times 1 is equal to 1 times 1 plus 1. That is, the left hand side is equal to 2, the right hand side also equal to 2. 2 equal to 2. That means the result is true for n equal to 1. That is, P of 1 is true. Okay. Now what is the next step? We assume that the statement is true for n equal to k. That is, P of k is true. We assume. That is, what is P of k? Sigma I varying from 1 up to k of 2i is equal to k times k plus 1. Now what is the next procedure? Using this statement for P of k, we prove that the statement is true for n equal to k plus 1. That is, I am going to add 2 times k plus 1 on both sides in the statement of P of k. We have P of k sigma I varying from 1 up to k of 2i is equal to k times k plus 1. Now here I am going to add 2 times k plus 1 on both sides. Okay. That is sigma I varying from 1 up to k of 2i plus 2 times k plus 1 is equal to k times k plus 1 plus 2 times k plus 1. Okay. Now I am simplifying the right hand side. Left hand side is kept as it is. Now what about the right hand side? K times k plus 1 plus 2 times k plus 1. Which is the common factor? K plus 1. I am taking k plus 1 outside. K plus 1 times k plus 2. This is the right hand side. What about the left hand side? Left hand side is summation over I varying from 1 up to k plus 1 of 2i is equal to k plus 1 times k plus 2. Okay, when we expand the sigma notation on the left hand side, what are the terms we are obtaining? 2 plus 4 plus 6 plus etc. plus 2k plus 2 of k plus 1 is equal to k plus 1 times k plus 2. That means the result we have proved is true for n equal to k plus 1. Therefore, the given mathematical statement is true for all natural numbers. Okay. Now we can verify ourselves also. Give me any number n. Okay. Give me any number for I. I varies from 1 up to 3 or n equal to 3. That is sigma I varying from 1 up to 3 of 2i is equal to, what is the value of n here? I varies from 1 up to 3. N is equal to 3. 3 times 3 plus 1. Okay. What is sigma I varying from 1 up to 3 of 2i? That is, put I equal to 1, we have the first term as 2, plus put I is equal to 2, we have 2 times 2, that is 4. Put I equal to 3, we have the 2 times 3, that is equal to 6. Is equal to, what about the right hand side? 3 times 4. Are they equal? 2 plus 4 plus 6, that is 12. 12 is equal to 12. Okay, the result is true for n equal to 3. Similarly, we can prove that the result is true for any natural number. You can prove it by yourself. Put n equal to 5. Let us see one more. When n is equal to 5, what are the results obtained? Is it true? It is sigma I varying from 1 up to 5. Okay, of 2i is equal to, what about the right hand side? I have to put n equal to 5. That is 5 times 5 plus 1. Now put the values for I. First value of I is 1. 2 times 1, that is 2, plus I equal to 2. 2 times 2, that is 4, plus I equal to 3. That is 2 times 3, that is equal to 6, plus I equal to 4. That is 2 times 4, that is 8, plus up to 5. 2 times 5, that is equal to 10, is equal to 5 times 5 plus 1 is 6. What about the left hand side? 2 plus 4 plus 6 plus 8 plus 30, is plus 10, sorry, that is equal to 30. And on the right hand side, 5 times 6, that is equal to 30. 30 equal to 30. Both sides are equal. Therefore, the result is true for n equal to 5. You can verify by yourself putting any value. Put n equal to 20, 30, etc. You can verify. That means the given mathematical statement. What is our statement? Sigma I varying from 1 up to n of 2i is equal to n times n plus 1. This is true for all natural numbers. Okay, you can stop today's class. Thank you.